Hello, everybody. I am Dr. Anthony Davis. I'm the Senior Manager of Employee Development and Engagement here with CodePath. And I am excited to be helping to moderate this session. Um, so we're excited to have you. So before I start the next session, um, I just want to introduce a few things. So we just want to remind you all to make sure you're utilizing the chat for your comments, all of making sure you put everything within the chat. Okay. Please take a moment at the end of the session to give us your feedback as well. Um, and uh, and from there, I'm just excited to introduce this next session. So the next session is going to be called Beyond the Scenes of AI at Scale with Bobby D. Okay, and let me give you a little background about Bobby D. Bobby D is a seasoned engineer and professional speaker with 20 plus years of experience in technology and engineering, specializing in the practice of site reliability engineering with the emphasis on hyperscale distribution infrastructure. Bobby D is known for his outgoingness and historic knowledge of Twitter tech and DNI journey, where he worked for 9 years, becoming one of the only few Black engineers to achieve the title of staff engineer. As Bobby D journey continues, he looks forward to the opportunity to continue contributing to his community. Hashtag the Tech Hustle by mentoring, coaching, and teaching the next generation of tech and the value of our diverse perspectives. So let's give Bobby a round of applause as we bring him to the stage.
What's up? What's up, everybody? Anthony, thank you so much for that introduction. I really, really hope everyone has had a great few days or few hours getting EES started, and I can't imagine how the next few days will be. Today's conversation, and I believe it's titled, let me see what I wrote down here. Sometimes I'll be forgetting. It says Behind the Scenes of AI at Scale. And we're basically going to be really talking about tech today. I'm one thing that I always enjoy doing, especially with mentees that are getting introduced to the industry or may not have attended a real hardcore tech talk. I got one for you today. Now, don't beat yourself up if there's any technologies or any terminologies that I may use that might be a little bit over your head. It's all right. But it definitely gives you an opportunity to let you know of what skills you can close in terms of gap, but also why I'm in these streets, as a mentor, a coach, and definitely somebody that's been around the block a few times. And we're going to jump into the slide deck and definitely get you all a chance to see what I've been talking about. Let me see if I can click the button here. Let's see. All right, perfect. Yes, it looks like my slide is on screen now. And yeah, we'll jump right into it. We are going to be talking about behind the scenes of AI at scale from distributed systems or distributed inference to system reliability. And it's presented by me, Bobby Dorless. Now, I know some of you may have met me today earlier. Big shout out to y'all who attended the keynote speech and definitely the opener. And y'all probably going to see me on camera throughout the next 3 days. But I want to give you all a little bit more formal introduction on myself, talk a little bit about my journey before we jump into the conversation here. And I definitely want you all to use the chat room to throw questions out there. The team is here to support us to get me questions in front of me if there are. But definitely closer to the end of our conversation, we'll definitely have some chances for more questions. But a little bit about me. As mentioned, my name is Bobby Dorless. I'm a technologist. I'm a conscious engineer. I've been at the keyboard for more than 20 plus years. I know sometimes it sounds a little intimidating, and I like to make fun of it because I do want to let you know, like, at the end of the day, this is not new to me, right? I've been around the block a few times and definitely have seen technology iterate from back in 2002 when I first started to where we are now in 2025. And I tell you, my mind is blown in terms of where we're at in terms of the iteration and progression. I'm the founder and CEO of a tech community called the Tech Hustle, where our goal is primarily focusing on mentoring and coaching the next generation of engineers by using different mediums like featuring on platforms and organizations and companies like CodePath, to running a podcast where we have a podcast where we speak weekly about technology engineering. And if you haven't heard yet, we run a really cool newsletter that publishes monthly, talking about tech really from a different perspective. Not going to give you no sales pitch here, but definitely want to encourage you all to link up with me on LinkedIn, find our website, www.thetechhustle.com, and get registered for this free information that we're giving out there because one day I might start charging for it. Now, in terms of my background in technology and engineering, I mentioned that I've been in the field of engineering for 20 plus years. I started off at the help desk. So my journey into tech didn't come from, attending a school in college wise or getting an internship and then eventually getting a really cool job. But it actually started off working at, the entry level position in terms of technology being the help desk. I did attend a little bit of schooling where I only had 2 years of technical school and used certifications as a way to level up. But I really enjoy my journey because I've really seen from in the mud all the way to working at a famous well-known social media company called Twitter. At Twitter, I became one of the lead engineers for the compute platform there, and this is why this talk right now is so dear to my heart because designing and building computing infrastructure at Twitter scale is, and sometimes I always tell my mentees it's like one in a billion chance that you were able to see it being done, and let alone these hands actually built it. So I know what scale really looks like, because the team that I managed for almost 5 years, I was there for almost 10 years, 2013 to about 2022, right before Elon Musk got here. So I know a lot of people ask questions about that. So I don't really know about what happened after Elon Musk. But during my tenure there, I really foundationally worked on teams that build data centers, build infrastructure, and actually build the platform that 90% of all of Twitter ran on. Now, I may have mentioned some technologies out the gate already where I said data centers. Data centers are basically these big old warehouse buildings, and we stack computers from the floor to the ceiling, and basically somebody needed to manage and design systems and infrastructure that was going to support that, and that's what my team specialized in. My skill set is in software engineering, but I'm also a systems engineer, is actually where my most proficiency at. I'm a Red Hat certified engineer. I know from inside of a computer how all that stuff worked, to connecting it to the internet, to eventually installing apps and making the world depend on it, right, in terms of reliability. And more specifically, my title at Twitter when I left was a senior staff site reliability engineer. If you're familiar with site reliability engineer, it definitely revolves around designing and maintaining the reliability of a site. And the site that I was responsible for was Twitter, which sometimes after I look back really blows my mind in terms of the scale that we're at and actually how much the world depended on it. And a lot of people didn't know that it was me back there, taking care of different things. So much so that this is the reason why I'm passionately into talking about technology at a really high level. Because number one, you don't see that many people that come from a community that looks like me and you that have worked at that level and can come back and talk about it, right? And that's what I'm really passionate about. My mission, as mentioned here, is that I'm really trying to transform the tech landscape by empowering the next generation of engineers, because there's this wave. And I mentioned this in another talk that I did on stage a few weeks ago. There's this wave that's only two letters, and I know everybody knows it's called AI. And the cool thing about waves are if you turn your back on a wave, right, you'll get hit and knocked right over, right? I'm from Florida, so we go to the beach, and that was like number one rule: don't turn your back on a wave. What you should do is position yourself, line yourself up for a wave, and get ready to jump when the wave comes, right? And that's what I feel like AI, in terms of what I'm going to be talking about this evening, is how we're designing and building infrastructure to support this wave that's approaching. And it's truly is cresting at this point. So I do want to encourage you all to dial in. Like I said, there will be some topics that I'll talk about that might be a little bit over your head. That's cool. Write them down so you can go check out some, terminologies or some specific skills that we're talking about. But the main thing here that we're talking about today is, what is the challenge with AI at scale? Now, I know most of y'all have heard AI. I know most of y'all have used AI in some capacity. If you haven't used AI yet, I'm gonna be straight up. This might not be the industry for you because if you're not already using AI right now, you're already getting left behind. And I mean this wholeheartedly, not to throw any shade, not to downplay your progression and where you're at in your journey. I just want to encourage you to use it every single day if possible. But there is a need to build computing infrastructure to support the scale that all of us technologists are talking about, where we're going to be going towards. And the challenges that we run into in terms of scale is in those buildings that we talked about as data centers, there's limited of space, right? How many computers can we get into that one building? Another challenge is how much cooling. Like if we stacking computers from the floor to the ceiling, how are we going to cool all those computers? I mean, you've walked around before with your phone which I don't know if you knew is a computer in your pocket. Yeah, yeah, yeah. But if your phone is overheating or you left your camera on, right? And all of a sudden on the side of your pocket, or you may have it on the table, you feel your phone and it's warming up. It's because it's heating up. Now, inside of data centers, these racks of computers that's depicted right here in this illustration creates a massive amount of heat. But you need to build a system and infrastructure that supports the heating and cooling of computers, especially when we're talking about GPUs. Now, the other side of that is not even just the building, and we're talking about cooling, but the demand for power. I don't know if you all knew, but the amount of computing power that is needed for us to take the next leap in AI, we don't have it. I read a paper the other day that said if every AI lab turn on their AI, the United States power grid will just crumble. Especially with all the projections of how many data centers and new projects that are being kicked off. And I don't know if you've seen some of these ticket prices. They're talking 500 million. That's $500 billion. I apologize, 500 billion. That's $500 billion of investment that all of these companies are making and building out this infrastructure. That's why this talk like this, in terms of talking about AI at scale, especially now you're getting into your career, is going to be pivotal in terms of your iteration of where you're going to be going in terms of direction. Now, computing as a demand, right? Um, it is a multi-billion-dollar industry. Low key, I feel like AWS, GCP, and Azure, or whatever Microsoft calls it, Azure, is the new hustle, right? A lot of companies have already moved to the cloud, but the cloud is actually real computing resources. I'll tell you a quick story. I remember I was talking to a mentee of mine about what the cloud is, right? And it was a younger student that was really interested in tech, but couldn't really find where their lane was. And we started to talk about cloud engineering. And we started to really dive into what is the actual cloud, right? And this may be something that you have pondered, right? Hey, I have computing resources, I have my emails, I have this database that I can access, and it's out in the cloud somewhere. But what is that? And there's this thing that I always want to remind you: we are communicating from one computer to the next computer. When your phone connects to the internet and it connects to the cloud or connects to a service that's running in the cloud, there's a physical computer that is running that process. Even though it's virtualized, even though it's containerized, there still is a physical computer that you have to talk to on the other end. Now, who manages, who develops, who designs, who supports those computing resources? A lot of companies, as I mentioned, decide to move to the cloud because managing computers is a tough job, right? And even as an attestant to this is how many students are actually studying, systems engineering. In the chat, throw that in there. Like if you are studying systems engineering, put a +1. But most students, or most CS students especially, are studying more on the computer science, software engineering side of the house. But there's this other practice around computing resources that out there, and that's why talks like this uplifts us on the systems engineering side of the house, but also gives us an insights into the value around our skill set. And I'm gonna say that again: the value around systems engineering skill set. If they're talking a lot about software engineering and AI having a battle, there's still going to be a need for systems engineers to build infrastructure at scale. But the other part about compute, right? And this is something that I always learned while working at Twitter was um, there's always two sides to the coin. One is that you build infrastructure that's going to be managing compute. And let me just roll back in terms of what I mean by compute. Compute is when I'm talking about CPU, memory, and computing resources, right? If you write a program that you're going to schedule in some type of cloud infrastructure, you need computing resources like CPU, memory, disk, and network for you to run that process. But you also need a place to store your data, right? And that's why data and compute are always considered as two different entities, right? And that's why when I break it down into the challenges with scale, they're actually two separate challenges. And even on the compute side, I forgot to mention a technology that I hope you all get familiarized with, which is called GPUs. It's another type of processor that we usually utilize in graphical processing, especially with the number one hardware provider being Nvidia, we used to put these graphic cards in home computers so that you could play your video games better. And now these same graphic cards are being used to train, but also, distribute inference for AI. It blows my mind that that computing technology has gained so much popularity, but that resolves in the compute platform. Now, on the data side of the house, the most important thing about data is number one is accessibility in terms of how can I access the data that I need? How can I access it reliably? And how can I access it in a way that doesn't hinder me from processing whatever I'm doing, right? Either I'm storing it inside of a database, right? So that's more like that's like a Postgres or MySQL. You also have NoSQL type databases like MongoDB. Do I store it in, let's say, even something more simpler than that in a raw file called SQLite? SQLite's a great example of storing data in a specialized way that makes it easily accessible to anyone. And then you can even go deeper into that where you're talking about object stores, right? So it's like, hey, and we'll use Twitter as an example, as all these tweets are coming in, we need to store all of these tweets inside of an object store, or in some cases, a key value store where we say, hey, this is the key for the tweet, and then the results in terms of the data is actually what's inside of the tweet itself. Object store and blobs are going to be like images, like whenever you upload an image to, let's say, Instagram or Facebook or even Twitter, they're being stored in an object store system and a blob store system that allows us to be able to serve that back. But if you notice something, you can see that these two entities are treated as two separate things, right? And the thing about data, and if I would have known this even more as I was coming up in the industry, is how valuable data is. I actually tell my mentees that data is by far one of the most valuable assets that companies create. And sidebar, the reason why Elon paid $44 billion for Twitter was the amount of data we had about everything. And I mean, we had tweets from the first tweet. And yeah, we deleted tweets, but we've always maintained consistent copies of tweets replicated all around the world. Now, that data, how valuable is that data when you're training AI? Do you see the connections? Like being able to maintain and support data for long term storage, either being hot or cold storage, but also utilizing data in a way that we didn't even know that we were going to be utilizing it to train AI models is massive. And if I recall when I left, uh, Twitter had hundreds of petabytes of data that I know for sure were being used to build out different type of models, like whatever XAI is built, and also other AI labs that actually had access to backend data at Twitter. And overall, the thing that I want to emphasize here, especially about challenges of scale, is that we're not dealing with gigabytes, we're not dealing with terabytes, we're definitely dealing with petabytes of data that you have to design systems so that you can scale as you're growing, but also utilizing them. And then reliability requirements, right? I think that right now, AI in its current form is really taking advantage of what we've built in our industry in terms of reliable services, right? The simplified interface to access OpenAI is an API call, right? An application programmable interface that relies on a RESTful API that's in a JSON type data structure that if you have a access key or token, well, I would say more of an access key, an API key, you can access the API and then you receive data back from an API call in JSON form. I mean, AI was basically primed to be in a more reliable state because of a lot of the technologies that we've built out throughout the years. And definitely something that I lean on as a site reliability engineer on a daily basis is definitely the reliability of systems. Now, when you're talking about what hyperscale architecture looks like, we talked about compute, kind of dived a little deeper into, the past experience at Twitter and really, visualizing what the cloud is. Also a new computing resource called GPUs. And then you have storage systems that actually store actual objects that are utilized by AI for training, but also for just storing data in different type of formats. But when you think about what scale looks like, and this is illustration right here that really gives a quick depiction of how clients that are all the way on the left hand side, the little small client, accesses OpenAI, which is all the way in the back, right? Is there is a lot of opportunities for us to design system and architect them in a way that sometimes make it look even more simpler than what it really is, or sometimes it's a little too complicated, and then that's why users have a kind of unpredictable experience. The one thing that I always like to teach, especially when I was mentoring at Twitter, is keep it stupid and simple that anybody can just come in and pick it up and keep it running. And that also applies to when you're designing systems. Now, I am using this word system design, designing systems overly obsessive right now, because whenever I hear a mentee talk about they're about to go to an interview and they have this interview called system designs, this is what we're talking about, is what does the infrastructure look like when you're designing the flow from a client to an AI or an API call in the backend system, right? But all that's in between, especially at the compute layer, also includes the different type of hardware that you potentially would have access to. We'd already talked about GPUs. There's something called TPUs. I believe Google's created that and have a more proprietary build out of hardware. And actually, I just read something today that OpenAI is partnering with, I believe, Broadcom or some other company that makes chips, and OpenAI is going to build their own chips, right? This is where the industry is moving. Like, it's like, hey, we don't need anybody else but ourselves, and they're making real large, big investments into building out these computing resources. But when you're thinking about architectural wise, let's take a look at this diagram here. You'll see that the client talks to something called the edge, and the edge kind of is the kind of middle person between cloud and then the cloud being able to talk to the backend system being OpenAI. Now, when we're talking about the edge, this right here is something that I think a lot of users don't realize how we trick you all on how something called latency is actually achieved. If you're familiar with latency, latency is the time it takes for a packet to go from my computer to the other computer and back, right? And we want everything in under 200 milliseconds. If you're not familiar with 200 milliseconds, when you get a chance, go on Google, go on ChatGPT and say, what's the importance of 200 milliseconds to a software engineer? And you're going to get a plethora of information around what 200 milliseconds means. But the 200 milliseconds means that we have to make all of this happen before the clock runs out, which is 200 milliseconds. And when you move things closer to the edge, what does that do? It basically reduces latency. Now, sometimes you'll have to go from the edge to the cloud or into a physical data center, but your first line of defense to reduce latency is always moving stuff closer to the edge, and then go home if you have to, right? And then going home obviously has to be designed in a way that allows for for fast response and lower latency also. And then that's where a lot of these distributed systems come into play, such as distributed file systems, object stores, and more or less the way that you design storage systems to react. And why do I jump from compute to storage? If any processing happens in compute, it happens the fastest. Any processing that happens in compute and also attached to physical memory, like memory inside of your virtual physical box or your container, everything is fast. Soon as you have to exit out of the CPU cycle, memory that's local, and you have to go and fetch things across the wire for data. This is usually done through let's say a SQL call, or let's say Postgres, MySQL, key value store, whatever. You're increasing latency. That's why storage, in terms of comparison, is always honored in terms of how you have to design storage systems so that you reduce latency. One of the coolest storage systems I ever worked on, and this is another sidebar, is something called Redis. Redis is a database engine that's written in memory. So now imagine you're accessing a storage system where you have to leave your CPU and memory and then go to another storage system, and its data is stored in memory. Obviously, that's going to make your response even faster, right? We use Redis for a lot of caching. We usually have it on the edge of the internet, but you find backend systems taking advantage of some of those really cool ways of storing data in memory, but also this is where algorithms really come into play in terms of how you're storing items. Let's say from an array to a set, right? You definitely have two different big O notations if you're writing to an array, O of one, and then a set is more or less being able to respond even faster, right? But in general, these are the differences that you have to consider from compute to storage, and then an orchestration layer. Now, What I mean by orchestration layer? One of the things that a lot of people don't realize is the amount of effort that it takes to manage and build out this infrastructure, right? I'm talking a lot of terms here: compute this, storage that, but how does this all tie together, right? This is where the orchestration layer comes into place, where you're really designing systems to be more, how can I say, very generic, and when you're scheduling computing resources. And what I mean by this, I talked about a tech earlier. I said something like virtualization. I also mentioned something like containerization, but there's this platform that sits right above all of that, that basically has, for better or worse, become the more standard way of creating a more orchestration layer, and it's called Kubernetes. Not sure how many of y'all know about Kubernetes, and definitely want to encourage it as something, the skill set to develop. As a software engineer, you're basically interfacing with Kubernetes to schedule your workload, but as a systems engineer, you're building the infrastructure that's going to run Kubernetes. Some really cool stuff, right? But Kubernetes as an orchestration platform is only one example, and it's definitely something that I've grown and really appreciated over the years, because while I worked at Twitter, this is another little sidebar. We build our own orchestration system. So I don't know if you all knew this, but even with Kubernetes, and the system that we built at Twitter called Mesos and Aurora, and what Facebook runs, they run something called Tupperware, is all foundationally based off of a platform created by Google called Borg. It's a great research paper to read up on. Definitely want to encourage you all to take a look at what it looks like to design a system to be hyperscale, and definitely fall aligned with what we're talking about. But Borg itself is basically the beginning of where we change the concept of computers being individual objects themselves, and looking at that big data center as one big computer. I know it doesn't make sense, but just imagine when you're managing computers individually, right? That creates, number one, toil, and obviously you need to increase headcount because you're managing each computer individually. But when you put it under an umbrella like an orchestration system, like Borg, what Google created, and then one of the the new products that came out of Borg, which is Kubernetes, it allows you to look at your infrastructure in a different way, where you're looking at the whole building as one computer. And then you're looking at applications where you just schedule those applications anywhere in the data center, right? It's some really cool tech, and I definitely want to encourage you all to double tap on what orchestration looks like. Now, even with orchestration systems, storage systems, and obviously we talked about compute, we're talking about AI here, right? And I'm not gonna. Actually, I did mention her name earlier, but I'm not gonna give you any financial advice. But if you are keeping a track on the value around the company that is the primary developer of GPUs, you can quickly understand why I'm going to stand on this. Is that this technology, this hardware technology called GPUs, will be the future of what computing looks like. And we need to understand how GPUs differ from CPUs, from the way that they process memory, to parallel processing, and more or less how there might be other hardware accelerants out there that could accommodate some of the similar use cases of GPUs, but more specifically, GPUs as an optimization technique is something that I really want to encourage you all to dive a little deeper into. And remember, I know most of you might be at the software engineering side of the house. There might be a small few of you at the systems engineer, but there's definitely a gap in the bottom called hardware engineering that I want you all just to spend some time, maybe read one or two research paper, follow along, and be familiarized with this technology, because this tech influences the stacks above it, right? So if we're designing a system or designing a hyperscaled AI system, and a software engineer doesn't understand what computing resources we're allocating, they may be designing the wrong type of system to run on that platform. And it's happened before, right? And that's where the gap, and in my opinion, always need to be closed. And opportunities like this for software engineers to learn the low level infrastructure things is definitely one of those chances to be very inspirational, right? Um, so the other thing that I want to make sure I mention in terms of scale itself is what distributed inference systems look like. So when you're talking about interacting with an API, This is definitely something that I always like to quiz, potential candidates is what happens when you type in www.twitter.com and you hit the button enter and you traverse the internet to get access to whatever, let's say, backend data that you're accessing through an API. That same model is what plays with us in terms of our interface today. And it's a model that leverages some already existing technology like load balancing. And then you see me talk about latency optimization. And more or less, what we're talking about is the model service architect. The model service architecture looks very similar to RESTful applications or backend systems. I'm not sure how many of you all are on the backend side of the house. Me, my most proficient programming language is Python and Go. I usually write, if I'm writing a backend system, I'm using Flask or Fast API. And I know a lot of you are out there that, write and utilize Java and or Go or even just Node.js as a backend system. But all of those skill sets apply to what's going to be coming up in AI. And that's why I bring it up is that a lot of the conversations that you'll hear a lot of people talking about AI is the model building. This is where they're building those massive gigawatt data centers where they're just going to run, the build process that takes, 6 months to get through. What I'm talking about is the results of that. So after they run the build process, there's this binaries, these sets of binaries that basically is the binary of the AI. But who's going to serve this binary? This RESTful type of API system that you'll access and what we access right now. And that's why I more or less want to just emphasize that this technology, this modern way of interacting with data, doesn't change as much with AI. It's just a different backend system that, or what I mean by backend system, I mean like when you build an API, you build an API and then you have a database, right? But everybody interacts with the API. The database can change, but the API doesn't change. That same concept is what's being developed with with AI and OpenAI definitely utilizing it. Load balancing strategies. Now we can talk for hours about load balancing, and definitely want to encourage you all to familiarize yourself with this technology around round robin. Let's say there's different technologies like Nginx, HA proxy, but these type of architectural resources and tools, and more specifically models, are not new. So that's why I'm always encouraged, like especially if you all are developing the skill sets, is that there's a lot of resources out there to dive even more deeper into it. All right. Now, in terms of what reliability engineering for AI looks like, right? I started off earlier talking about while working at Twitter, I was a site reliability engineer. Actually, right, what his name is site reliability. And yeah, the site's reliability depended on my group of engineers. And the same thing comes into play for AI, right? Is that you're designing systems that are going to be fault tolerant and gracefully handle failures, right? When we talked about load balancing, if you're not familiar with load balancing, it's basically like a traffic cop. When a packet comes into the front door, the load balancer receives it. After it goes to the firewall, the load balancer receives it, and the load balancer says, "All right, you need to go this way. You need to go that way. You need to go this way." Right? And it's more or less optimized for failure because if one of those instances that it's going to throw the packet to doesn't exist no more, load balancer says, "All right, I won't send no more packets there. I'll just send it somewhere else." That's what fault tolerant designs and those type of strategies really come into play. Monitoring and observability. I have a saying with my mentees that if you have a service that you do not monitor, then you need to assume that it's broken. If you're not collecting metrics on a service, then it's broken, right? Is monitoring and observability of the performance of not just the overall infrastructure, but down into the instance of applications or instance of AI, it's going to be a needed feature or skill set that you should develop. And then incident response. This is really what site reliability engineers really focus on. Is how do we not do the same or how do we not have the same problem more than once, right? I used to have a saying, if something failed the first time, it's okay, but if it failed the second time, then it's all our problem type thing, right? And you definitely want to make sure that you have processes in place, especially when you have incidents with AI. And I've been following along with OpenAI. Each outages that they have, I'm subscribed to their status page, and they are definitely showcasing what it means to run systems at scale, but also at a production level, because you have these normal practices in place like incident management. Now, what does the real world look like and use case for AI? And we're going to quickly skim through this because we've already kind of talked about Google, Microsoft, and a few other cloud providers out there. But just know that this technology this infrastructure, this scale is going to continue to grow. And there's still going to be a need for the skill sets around for companies like the ones I listed here to really get through the process itself, right? So definitely want to encourage you all to follow along these companies in terms of what their real world use cases are. Especially Google, I mean, if I go back 2 years ago, maybe even less than a year ago, I thought they were lost in this fight here or this, competition around AI. But as of late, they've been killing it. And I knew they had the computing resources, and I also knew that they had the engineering capabilities to really take us to the next leap. Obviously, they were the ones that wrote the transformer paper on how to teach and train AI. So I knew that they were going to catch momentum. But there's always something that I want to encourage you all to follow along, read up on these research papers, use case, and understanding the technology below. Especially when we get to like virtualization and containerization, because that's how we actually manage and run at scale. Um, and the future trends, things that I really want you all to keep an eye out for as you're going through your journey, especially as you are, getting familiar with how this industry shifts and change, is that you'll notice that uh, hardware associated with AI is only going to increase, right? There's a demand for us to achieve a certain level of AI, and you can't get there unless there's innovation in the hardware spectrum or the hardware side of the house. So if you are electrical engineer, mechanical engineer, and or like me that likes to break things, right, is definitely want to give you some words of encouragement that in terms of pathways to supporting scale and growing an AI scale is definitely building up efficiency around that. The other one that I mentioned here is edge computing or edge cloud hyper or hybrid computing. There's this quote that I actually been, mentioning to a lot of friends of mine about where the edge of the internet is. And let's just get some clarity first. What is the edge of the internet? First of all, think of the internet as if it was a highway, and literally it is a highway. There's wires that run under the sea, across the country, across the world to connect us all on this highway, right? Some of it is being beamed out to space. Obviously, Elon Musk got some, satellites out there, but majority of our internet traffic happens on the planet in physical fiber optic cables. But those fiber optic cables have centralized points that they connect to. It's just like a highway. When it gets to a city, that intersection or that junction is considered the edge of the internet. And what happens is a lot of companies put computing resources right when the edge of the internet intersects, right? There's certain points and places in the United States that, you'll find more data centers being developed because that's where the edge is. And the closer you are to the edge, the faster latency you have, right? So much so that I also have this feeling that the cloud providers are going to be the new edge of the internet. And what I mean by that is everybody's scheduling everything out in the cloud. Why do I have to leave that building to go somewhere else to be on the edge per se? I should just stay inside those buildings or stay inside that region, and I'm on the edge of the cloud edge environment. And that's why just talking about edge, I think over time it would evolve, and that infrastructure in terms of scale is going to have a high demand for AI. And think about just sustainability. We talked about challenges of data centers, cooling, power, and all of those difficult conversations I've had in the past. When we built a building out there, we filled it up with computers, and we're about to go to production. And then the facility teams come up and tell us, like, hey, we can't keep this building cool enough. So we can't, right? It's like taking those things into consideration when you are building scale is always something to put on the table, and definitely something that you want to plan in the future. But hey, we were able to get around some of those challenges. And then we're coming really close to the end of our talk here, and definitely want to cue you all up for it. If there are some questions, I believe Anthony will come back up or throw them in the question screen here for y'all to jump in. But some of the key takeaways that I want you all to know about scaling AI and understanding this, wave of impact, but also an opportunity for you all to develop, is architecture matters, right? Hyperscale AI systems requires like thoughtful multi-layer planning and architectural skills. It's not something you get just out of school. It's something you build over time. That's why when I hear candidates talk about the system design interview, it's usually something we reserve for a more, a level two engineer or someone moving into a senior staff level, right? But you also have a deep respect for architectural design because it does matter, especially at the beginning. And then we're always trying to optimize or being optimized with the computing resources, and definitely take in consideration the future development of technology, right? I know the GPUs are the hottest things on the street right now. I definitely want to encourage you all to get familiarized with the use case, but definitely don't want you all to lose out on where we're going in terms of other tech. And then reliability designs. Just know that the design of your infrastructure is really and should be foundationally principled on a few things. SRE practices is by far, in my opinion, obviously because I was an SRE and I really support the movement, is definitely one of those primary kind of say means of developing a reliable system. And the reason why I say this, and I'll take a quick sidebar on this, the reason why I'm so like shouting from the mountaintop around site reliability engineering, I don't know if y'all were around maybe, 10, 15 years ago when everything used to break. From Facebook, from Instagram, Twitter used to break all the time. Yahoo used to break, AOL, all of these systems used to break all the time until a team really put together different practices that got us all aligned in where we should be focusing our time on reliability. And site reliability came out of Google. So big shout outs to Google again. But this practice itself is something that I do want to encourage you all to familiarize yourself, because when you get to the industry, when you get into your full time job, the most scariest thing for me is when I break something or when something's broken and I don't know how to fix it. And the thing that you have with SREs as a practice is different ways that you design systems so you don't get that feeling, right? That feeling like, oh, if I deploy this, will it actually work? And or if everything breaks, what do I do, right? But I always do want to encourage that this idea around SRE principles is something considered in design strategies that you all will be exposed to. So I do know that I guess we have about 8 to 9 more minutes left on the clock. So if there are any questions, I'm going to click the question bank here and see what we have here. I'm going to see if I jump into some of these questions. I hope you all enjoyed the talk. And definitely, if you are looking for some more insights, follow your boy. I can easily be found on this thing called the internet, and definitely LinkedIn is a great way to get connected here. All right. So, one of the first questions we have here is, let me see, for someone who is getting into SRE and the aspects of distributed systems, can you tell me a general overview of what you would do if you have to start again? How would you get experience? That's a really great question. So, one thing that I would do for SRE, first of all, is building up two proficiencies and two skills. If you didn't notice, I started off saying I'm a systems engineer, or actually, I did say I was a software engineer first, which I usually don't, but I start off saying I was a software engineer, but I also am a systems engineer, right? And I'm having two different skill sets in terms of proficiency. It could be a database administrator and also systems administrator, right? It could be a software engineer that manages front end, but also back end that fills that skill set around site reliability engineer. And what I mean by building proficiency is building a level of proficiency to understand what's going on in both lanes so that you can be prepared to provide that reliability support. The second thing that I would do is I would no doubtedly like be reading and reading even more that's online about site reliability engineer. Let me see if I got the book right here talking about the book. Great resource. I'll put it right here. There's no plug. Nobody's getting no money off of this, but definitely. It looks like somebody asked for what is the book recommendation. So I already dropped it out there. It's called Site Reliability Engineer: How Google Runs Production Systems. It's a great, great book, and I believe they actually have two series. Another good one, and actually, y'all got me, pulling out from my bookcase. If you're learning about Unix and Linux administration, this is a great, great, great handbook, and I can put these out somewhere afterwards. And then the last one I'm going to show is Cracking the Code. If you haven't seen this one or read this one, this is a really good resource, and definitely give you some insights into cracking the interview code. But those would be the areas that I would be developing. And if you kind of seen the different type of books I have here, I have software engineering books, I have systems engineering books, and I have books, on all type of topics. So definitely want to encourage you to check out some books. That's where I would start off with. And then the last thing is, hey, follow your boy, follow any newsletter or any topics around site reliability engineering, and definitely. There's a really good blog post or newsletter. It's called Byte Byte Go. I don't know if somebody can throw it in the chat room. I can't pull it up real quick, but the person that created that blog post is the same person that created the system design book, and he used to work at Twitter too. So He's a great resource, great technologist, and definitely has had some really good insights into site reliability and designing systems at scale. All right, so I answered that question. Let's see what else we got here. Um, Another question is, I'm trying to build a career at the intersection of AI systems and sustainability. What technical skills or infrastructure experience should I be prioritizing first to make myself a strong candidate for entry level roles? All right. So, what I would say is the cool thing about where we're at right now, especially with AI, is we are only, and I have to go check the calendar. I believe 2 or 3 years from when OpenAI released the first Chat GPT that everybody has access to. So we are really at the beginning of this journey. And what skill I would encourage you to develop is definitely utilizing this tool called AI to be more proficient, right? And it's not like, hey, um, AI is going to take my job. It's going to be, hey, the person that develops the skills to utilize AI most efficient is going to take that job, right? And the cool thing about AI, especially in closing the gap on developing infrastructure experiences, AI can be used as a way to teach you infrastructure skills. So much so that I have a mentee of mine that's going through a program right now that's only using AI to learn how the cloud works from first principle up to scheduling workload and some Lambda function, right? And really stretching that scope. Also on the infrastructure side, especially if you're thinking about cloud, is certifications. I know that certifications, at least when I was getting in the industry, early 2000s, was the hottest thing on the street, right? It really gave companies and insights into your skill sets. And I think this is coming back around. One of the reasons why I decided to take the Red Hat Certified Engineer certification, it was the hardest certification at that time. I got certified in that in '06. But once I got certified and Red Hat Certified Engineer, doors started swinging open, right? Is utilize certification as a way to get your badge and get your stripes on your shoulder. So when you are engaging with companies, they at least know that you have the capability and capacity to talk. They'll talk. And if the certification is a real difficult one, like the RACE, they respect you when you first walk in the door. So I don't know if you've ever heard about that certification. Check it out. It's RHCE. It's Red Hat Certified Engineer. Would be a way that I would encourage you all to level up. All right. So next question I have, is there a way that I can get in touch with you and contact you? I mean, LinkedIn, I'm always online. The internet is I'm friendly on the internet. So definitely feel free to reach out. Just know that obviously with EES, there's going to be a lot of people hitting up my LinkedIn. Be patient. I definitely will reply back and get connected. But hey, take a look at some of the cool articles that we have out there in our blog posts. We talk about tech. We talk about AI. Take a look at some of our YouTube content. Every YouTube that I'm featured in, I do a tech talk. So at the beginning of the podcast, I talk about something in AI and tech. And then I also travel the country and interview, some technologists that I've had a chance to work with. So it's easy to find me on these streets and definitely LinkedIn. Let's get connected. All right. Next question I have, and might be the last one I have here, is I'm trying to become an AI data engineer. I'm assuming I need to know everything from the hardware to making the model themselves. However, that seems like a lot for a single career. Any advice? All right. So, AI data engineer. So, anything with AI nowadays, and don't feel like you're being called out specifically because it's an AI data engineer. I think any role that has AI, ML, has data sciences, has some implications that you're going to be interacting with a model. There is a higher requirement or higher boundary to get into the familiarity of how the system works. And the challenge is that the bar right now is set extremely high. I mean, I don't know if y'all noticed, but they were writing $100 million checks for researchers from one lab from OpenAI to go to Meta, right? The bar is set really high. And when that happens, you always find the need for you to be able to develop even more insights into the technology to get recognition and or to get into the industry. So I don't want to like have you hold back from this idea that you're going to have to learn. And this is about everything in engineering. We always have to be learning. We whatever I worked on 5 years ago is already deprecated, and I got to learn again. Is get into the groove of really diving down into that niche and really sharpening the skills from beginning to end. From yes, understanding how hardware works and the GPU works compared to CPUs, understanding what libraries you need to use to access the GPUs that, let's say, a provider like NVIDIA has. From, all right, now I need to write a data pipeline using uh, PyTorch or TensorFlow, which are Python libraries, to create a pipeline to train the model. Actually, I need to be able to access a SQL database to query this data set that we're actually going to be training the model with. And actually, it's written in SQL on MySQL, and then it's also stored in this thing called MapReduce, right? Where it's just some unorganized key value stored. Like, yes, that is the spectrum from where the skill ranges from, especially when you say AI, data, and engineering. I do want to encourage you to pace yourself, continue to follow along, find a community that's really focused on AI, data engineering. So you have that community. I guarantee you can find it here at the EES. Put it out there, let other people know that you're interested in. And then, yes, I want you to go through that cycle to understand how you actually build a model so that you, when you're in an interview, you can really dive into the topic. And that's where passion really comes in, and actually kind of overlaps with the keynote that I heard today. Is focus and passion is key when you're really engaging with organizations nowadays, because there's just a lot of people on the streets. All right, I think we are at the end of our conversation, Anthony. Hopefully I did well and hold it down, my guy.
No, Bobby, you did amazing. We knew that already. Again, Bobby, we thank you so much for always just being a champion of CodePath and of our students. We really, really appreciate it. If you all can show Bobby just your appreciation in the chat, we thoroughly appreciate it. So again, we've come to the end of this actual discussion. Bobby, if you had one piece of advice, just one piece of advice, what would that piece of advice be for students that are afraid of this new wave of AI? Because
Yeah.
it's the talk is it's going to consume all of the jobs. So all of our recent grads and or our upcoming grads, they're worried about this. Like, what is one piece of advice you will give them?
Yeah. So just know that this iteration that we're on is something that I'm more excited than ever to see what will be created. You just have to keep the momentum, stay on this hustle. And what I mean by hustle is I'm not just applying for jobs through LinkedIn or through some job. I'm reaching directly out to companies and knocking on doors if I have to get access. You got to stay on the hustle. And then the last thing that I will say is keep your ears to these streets, because AI is changing so fast that within a week you can get lost. And if you're not staying up on this game, you're going to get left behind. That includes learning, that includes developing, that includes like spending the weekend instead of going hanging out with your friends. Actually, I'm going to go build an AI pipeline because I'm trying to build like that type of commitment is what you're going to need to stay up in the game nowadays. And I'm only more encouraged that you all heard it from me, and definitely here at CodePath as a supplemental education. And yeah, holla at your boy. I got you for sure.
Bobby, I have one more question for you, then I'm gonna let you go.
Damn,
Um,
Anthony, how are you gonna get two questions, bro? I'm just
so,
saying.
so what you say is hyper important to ensure that they have a portfolio of some sort, and or like their GitHub is up to date. We're able to see what they're working on, even their pain points. Is that important for employers to see?
Yeah, 100%. And thank you so much for that, Anthony. And this is the career coach coming out of me now. One of the things that you all may not know is I've interviewed hundreds of candidates. I said I worked at Twitter. You can imagine how many candidates I've interviewed. The first place that I go is I look on their resume for their GitHub link. I go to their GitHub and I pull up that page. Do you know what I'm looking for? I'm looking for the color green. If I scroll down to the bottom, there's a chart that tells me how active you've been. If
Mm.
you've been active, all right, yeah, we can holler. If you haven't been active, now I got to go figure out what you've been doing, because you're trying to apply for this job and we're trying to pay you $200,000. Like, that's where your activities, especially on GitHub, really is something that we honor, like technologists like myself. And it's not that we're looking to go dive and get to what exact, no, we want to see your progression. any work that you're doing is everything is work in progress. Don't wait until it's done for you to upload it to. No, we want to see what it was 6 months ago to what it is right now. And that's all visible on GitHub. And those type of portfolio projects are key for you to get recognition nowadays. So if I can encourage you, make sure that chart down there as much as possible is green, because then I know you're really on these streets balling.
Absolutely. Okay, Bobby, one more. Just in 2 words. In
Uh-huh.
2 words, what is your biggest piece of advice for emerging engineers? If you can do it in 2 to 3 words.
So there's this saying in Creole that says grand goût. Now this word translates into I'm hungry, but it's a different one. Is I want you to stay hungry. I want you to be grand goût. I want you to be more motivated than ever because that hunger, that's what's going to drive and get you across this line. Because at the end of the day, there's going to be a lot of people at this table, but the ones that hungry the most, the ones that really want to get it, or the ones that are gung are going to be the ones that come out on top.
Absolutely. There you have it, Bobby D. We appreciate you so much again, and we'll see you around. So from there, we're gonna close out with a quick video from Bobby D. And guys, make sure you take the survey. It just popped up. Make sure you take the survey, and we'll close it out with a video from Bobby D.
That a great session. Oh my gosh, these breakout sessions are fire, and I want to encourage you to attend as many as you can. But let me give you some information before we continue. So please take a moment to complete a brief survey to share your feedback. Remember, surveys are what's going to make us get better, but also let us know what we're doing really well. To see what's coming up next, you can head back to the main stage and check out the schedule. See you soon in the next session.